Good afternoon. My talk today is about the duckplyr R package. I've been working on this for the past 3 years together with Posit, DuckDB, and my colleagues at CYNKra. So thank you for this. DuckDB is an embedded analytical database, SQLite for analytics. Because of that, there is a variety of ways that you can package DuckDB as a command line interface, as a Python, Rust, WebAssembly, and also as an R package. I see 3 main reasons why you may wish to use DuckDB. If your data is large, DuckDB can read straight from Parquet and from other formats. If your data analysis or data pipeline is just a little too slow, DuckDB will make it faster. And then the third reason, DuckDB comes with a lot of exciting functions and data types, and there are extensions that add to that. All these are valid reasons to use DuckDB as a command line, to use the DuckDB R package. Now, duckplyr, to me, this is the interface that's more native to R, and I've tried to make this more accessible so that it blends in with all the other tools in the R ecosystem. Now, looking at ways to access DuckDB from R, you could do the command line at the bottom right. The more traditional way is through DBI. DBI is a generic package to connect to a variety of databases, including DuckDB. You would write SQL to interact through DBI or through the command line. If you enjoy dplyr-like interfaces, as I do, you would use dplyr that connects with DBI. dplyr translates your dplyr pipelines into SQL, runs it on the database, collects the results, but only if you tell it to. So dplyr works with lazy tables, and I forgot to mention, all of this will be available after the talk. You can run the code, and the slides are on GitHub. So dplyr translates to SQL, gets the data back as a lazy table. You can collect, but you also need to collect to get this as a data frame. duckplyr is similar, but different in a few respects. So first, there is no SQL involved. We use a lower-level interface so that we don't have to translate to text and back from binary formats. And second, you don't need to collect. So the data comes back as a true and proper data frame, and it will be materialized on first access. I'll show this. This is what it looks like to access a Parquet file. In SQL, through the command line, you give, in the from clause, the path to the Parquet file, just as you would give a table name to your box standard database. DuckDB will read the data from the Parquet file and do the operations. In this case, this is a simple row count, but this can grow much more complex. The more traditional ways of accessing DuckDB through R look like this. Typically, you would establish a DBI connection first, and then you could either, for dplyr at the top right, call this function that points to the Parquet file, returns the lazy table, and this then prints when you access it. DBI, you write SQL the same way you would with the command line. With duckplyr, this is, I believe, a little simpler, and you get back a proper data frame. Now, this is another example. I use a data set from Hugging Face. Instead of a file, I pointed to a URL with this HF protocol specifier that points to the location where the data set is. The same way as accessing a local Parquet file, I can run my operations. And here, the explain verb will show me, before I run the operation, what is going to happen when this operation is run. Starting with reading the Parquet file, you see we only need the 2 columns, so we only read the 2 columns. That's what the Parquet file allows. That's what the Parquet file format allows you to do. Then there is this aggregation, and because the dplyr verb sorts the result by the grouping variables, we also have this order by step at the end. I have prepared a demo. So just to show you how fast this is. This is over the internet, accessing this data directly from Hugging Face. I need to do 2 preparatory steps. The first is to get the extension that allows me the remote access. The second is to provide authentication, but then I'm ready to go. Personas is this lazy data frame, and this took no time. It prints, and you can use glimpse to get an idea what's in the data. This is 100,000 synthetic persons with sociodemographics and textual information on their preferences. So the explain for this example is a bit different. If it's the entire Parquet file, it knows the metadata, but again, as you run queries on this, you don't need to access all the columns. You don't need to load the data up front, which is important, I think, if you restart your R session very often. This was the aggregation. No, this first was the planning the aggregation. This is the computation. Again, all over the internet, very fast. And what I like best is you can offload this to ggplot. You can pipe this directly into ggplot. ggplot will know how to handle this data because there's nothing to know. This is a normal data frame for all practical purposes. Now, this was on the pre-aggregated data with geom_col. If we try to do the same on the raw data, bam, this is what happens. No, it's not going to work. The data is too large. This is not a bug. This is a protection mechanism I call prudence for some reason that avoids frying your computer. So try to access a column, try to do a row slice. No, it's not going to work. You can do this as soon as the data becomes small. So accessing one of the columns from the results works. The data is small, and this is how ggplot got access to the data. So I can collect the whole data sets if I want to, but no, I'm not going to. And I'm specifically proud of this because this actually gets out cleanly. So for large data, my recommendation is you can use remote access to peek into the data. Prudence feature will avoid getting data that is too large onto your local system. I forgot to mention, with DuckDB, everything's on the local system. You don't need a big server. You run everything on your workstation, still it's fast. If you decide to take a deeper look into the data, by all means, get it locally, because this still then will be faster by an order of magnitude or 2 if this data fits onto your disk. As soon as the code is ready for production, change one line of code, the way you access the data from local to remote, done. It's going to work the same way. Of course, analyzing large data is slow. The same can be true for smaller data sets. This is a completely synthetic example, 1 million rows, doing a simple summary over 40,000 groups. Took 5 seconds on my machine. Imagine multiplying this by 10. Now, if you have an existing dplyr pipeline, and this is one of the strengths and one of the original purposes that duckplyr was intended for. If you have a dplyr pipeline and you just want to get that a little bit faster, you have basically 3 strategies. You could go all in, try to do end-to-end with DuckDB. I think this amounts to a rewrite of the entire code. The best effort mode is the default mode. My recommendation would be to do a very targeted optimization of just the slow parts. Now, going all in means you set an environment variable, and this will not even get to the analysis because already the generation of the data tells us, look, I don't know what to do with this R norm. There is no translation for this. So even if we don't do SQL, we still need to translate, and we need to provide a translation for each and every R function that we use in the verbs. So this hasn't been done for R norm yet. I'll show later how to work around it. the best effort mode, the standard mode of operation when you attach the duckplyr package. At the beginning, it will tell you, look, I am changing the way this R session works. Everything you do with dplyr will go through duckplyr first. So we try with duckplyr. If it works, fine. If not, we offload to dplyr. Works the same. The generation works, and we see that the analysis, quote unquote, now runs almost an order of magnitude faster. 600 milliseconds elapsed. 4 seconds of user time spent means all the cores of my computer have been busy computing these results. The targeted mode is a little more, requires a little more work, but you get better control of what happens. So you don't let duckplyr take over. You undo what attaching the package does by methods restore. And this means that each operation will go through dplyr until you tell it otherwise. And the way to tell it to go through duckplyr is this as_duckdb tibble verb. I need collect to actually not only have a fair comparison, but to also turn this pipeline back into dplyr mode in this case. And for a large data pipeline for one of our customers, takes 30 seconds and is used semi-interactively, so this hurts. Adding this in 3 crucial places in the code cuts this down to 10. And looking forward to do 3 or maybe more. Identify the slow-running parts, add 2 lines of code, you're winning. The best effort mode, well, let me put it like this. There is a non-zero chance that the implementation will have different results with duckplyr than with original dplyr. And if your pipeline implicitly relies on this, so I'm talking about window functions that depend on the ordering. This is a weak spot. Could bring trouble, so best effort mode means you please check if the results are still the same. Of course, also with the targeted mode, but with the targeted mode, it is much easier to isolate. Now, we didn't have our norm, but this new dd: syntax gives us access to all the functions in DuckDB and the extensions that are available and loaded. So just by saying dd: random, we tell the system, look, there is no R function like this. Look for a DuckDB function of this name and run it for me. So this will be passed through directly to DuckDB and just work. We see the result as an almost uniform histogram. Now, the original code had our norm. This is not available in DuckDB, but there is an extension called stochastic. I found out by searching through a list of community extensions. And when I found stochastic, it was clear that this is probably where such a function would live. Bingo. Dist normal sample is available as soon as I do this load stochastic call, and I can run it to get this normally distributed samples. And again, piping directly through to ggplot gives the plot without any extra effort. This dd: is just an artificial syntax. So if you run this code in dplyr proper, this will not work today. But it is a package on GitHub that at least gives you the help pages for the function it knows. So there is a help for random, and 2 years ago at PositConf, I was very passionate about nested data, and I still am. So these 3 functions are the way how you can nest and unnest data with duckplyr. And if you're curious, this is the link to the material that gives you all the codes and much more to experiment on your own. Install from CRAN, run library duckplyr to attach the package, and maybe consider methods restore, at least for new code, to get operations for large data, fast, with a lot of goodies built in. Thank you.
Thank you. Plenty of time for questions. All right, first question. I think somebody wants a TLDR. Why build duckplyr instead of using dplyr?
So again, I think this is the interface that's more native to R. dplyr doesn't return data frames. dplyr returns a proxy object that you just cannot pass into ggplot unless ggplot takes measures to do so, which I'm not sure it does today. And if ggplot does, many other packages will not know how to handle a lazy table from dplyr, but they will know how to handle a data frame. So.
Thank you. How does duckplyr interact with Arrow?
Ooh. I have no idea.
We'll save an answer for later. Can I control when prudence kicks in?
Yes. So in all the functions that generate a lazy duckplyr data frame, there is a prudence argument where you can go either, well, I don't care how big the data is, to all the way down to always give me an error if it cannot be run with DuckDB. And the middle setting, that's the default when you read from a file. This will just break if the data hits 1 million cells by default.
Okay, and I think we can have one last question. How does duckplyr avoid the user needing to call collect? Once the data is small enough, does it call collect for you?
So no, the object is a proper data frame. I don't have this here, but in the demos there is this. So this personas thing, let me open this up. It has a class. The class is data frame proper with a few subclasses. This is essentially a list of R vectors of the same length, pretty much the same as a regular data frame in memory, but each of those R vectors is an altrep R vector. This is a lazy vector technique built into R core that allows to trigger computation just when it's accessed. So that's why we don't need to compute.
Thank you.
Collect.
Let's thank Kirill again.